अभी ठीक हूँ. So we are starting a very important lesson about the function. So I'm just going
Okay.
to share that. That is very informative, and this is all about those problems which are from the screen out. Those screen outs, screenshots. So let's see. So please read this one if you can.
Sure. Even function, function part one, odd function, types of function.
The types of functions. So basically, there are so many types. But sometimes the graph is given and you will have to nominate the types, and according to the behavior you will have to say that this is a even or odd function. So in this part, first part, we will talk about these, and will see some classic exemplary graphs of these two functions, and in the later part we will talk about the increasing and decreasing function also. So let's see. The first is, please read this one.
Sure. Even functions. If a function fx is an even function, fx is equal to f of negative x for all x in this domain. An even function has the important property line symmetry with the y-axis as its axis. This allows to plot the sketch the right hand side of the y-axis. Then, to complete that sketch, draw the mirror image on the left side of the y-axis.
Okay, so it's a very simple that if the algebraically you are asked to find whether the function is even or odd, so the simple is that if on every value equivalent to that negative value, the functions is the same, doesn't change this value or its behavior, then we can say it's a even function. And if in the second point is that even function has the important property line symmetry with the y axis as its axis. So it's lying on the y axis, and this y axis will become its symmetric line, the line of symmetry. You know, the line of symmetry is the line which
Yeah.
equally divides equally into the two halves or into the two shapes. So that is called the line of symmetry. So y-axis will become the line of symmetry. This shows us to plot the right hand side of the y-axis. Then to complete the sketch, draw the mirror image on the left side of the y-axis. So you can see that if this y is equal to fx, and for each and every negative x, the value is same. Both are the equal values. So we can draw the right hand side of fx. So this blue line is the actual graph of the function. And if it is a even function, so this y-axis will become the line of symmetry. So it's a symmetrical also. Even function is always a symmetrical function. So we can get the image mirror. What I mean to say that if you are just putting the image, so a mirror in front of this, so we'll get the image set. That image that is called the mirror image can be plotted over here, just like this red line. Now we can say that y-axis and axis of symmetry. So this is the y-axis now, and this is x-axis, and now this y-axis is called the line of symmetry. And a line of symmetry is a line which divides the curve or anything into two equal halves. Let's suppose if we are looking for the line of symmetry of the human face, so it will be straight down to the nose, dividing into two parts. So each every part have the same things: one eye, half part of the nose, half lips, one cheek. This chin is divided into two parts. So in that way, we can say that the line passing through our nose is the line of symmetry of the human face. But anyhow, this is the what we can say y-axis, and this will become the line of symmetry. So in this way, it is a symmetrical shape and we can draw it very easily. The right hand side and also y-axis in the this is on the left hand side. So it's a symmetrical also. So in this way, I'm sure that you can draw a lot of functions. You can recognize the graphs when the graphs are given and you are asked to find whether these functions are even or odd. I'm sure you're getting me.
Yes.
Is there any confusion about the definition?
No, yeah, I get it. It's like symmetrical minus
Okay,
even.
so there are a lot
Yeah.
of questions in delta math side also because whenever the shape is given, so automatically you will have to fill the values to check that behavior. If the value of the function at the negative corresponding values of that point is the same, then you can say that this is a even function. Now let's see, we are moving to the next one. So testing for even function. So this is more interesting. When the algebraic format of the function is given or when the graph is plotted over there and you're asked to find the nature of the function. So what you will have to do. This is the testing and it's a very interesting and also workable for applicable to each and every plot, every graph. Now let's see if you can read this, please. Starting
Sure.
from here, testing.
Testing for an even function. To
Yeah.
test whether a function is even or odd or neither, work with f of negative x and compare it to f of x. Usually it's also better to use x is equal to a and x is equal to negative a as the two values for comparison.
Yes. So this is these 2 points are actually telling you the what we can say the working rules that a function is given and you are not sure about that. That may be a very lengthy function that may be quadratic or any type of the equation is given and that is defined with respect to some domain also. So what you will have to do that work out for minus x. So out of the domain, you will have to select any two values. One must be the negative and the second one is a positive. You can put those values in the given equations. And if those values are the same for the positive as well as for the negative, then you can say that this function is even an even function. So it's a very simple way to get the nature of the function. Examples, please read this one.
All right. Show that f of x is equal to x squared minus 3 is an even function. Let's use numerical values x is equal to 3 and x is equal to negative 3. Evaluate f of 3 and f of x. Evaluate f of negative 3 and f of x. And then f of x is equal to x squared minus 3 and f of x is equal to x squared minus 3. Uh, f of 3 is equal to 3 squared minus 3, and then f of negative 3 is equal to negative 3 squared minus 3. F of 3 is equal to 6, and f of negative 3 is equal to 6. Now f of negative 3 is equal to f of 3, hence fx is equal to x squared minus 3 is an even function.
So it's a very simple. So I'm sure that you are getting all these things
Yes.
because it's a function is given, the equation is given. So what you will have to do, you will have to put the negative and the positive values. And if you are getting the same, so this is, you can see these blue lines on the right. These are describing all the way when you are putting the negative values. So here the function is this one and you are replacing each and every x in the function with minus 3 and after a simple calculation you are reaching at the 6 that is, and if you are doing all the things for the positive 3, this black portion what we can say on the left hand side, so each and everything is being done as it is as on the blue and the black. So the only difference is the minus 3 and the plus 3. So here you are testing the function at the same value but with the negative sign. at the same point, but on the negative side of that axis, that is the x-axis, and ultimately after the calculation, you are reaching at the same answer, that is 6, 6. So from here we can say that the negative value of the function and the positive value of the function at that point is the same. So on both the ends, you will be at the same point. One is on the right side and the second is on the left side of the axis. And in this case, you can say that fx is equal to x square minus 3 is an even function. And it will be symmetrical about the y-axis. If the function is given in the term of x, so the extra question is that what is the line of symmetry? So if the function is just like
Right.
that, so always your answer must be what line of symmetry is y-axis. Are you getting this?
So yeah. Okay, so okay, I get it, I get it, I get it.
Okay. Whenever you are asked to also find the line of symmetry, so sometimes this is the additional part, and the students are looking for that. That how can we find the line of symmetry? Line of symmetry is that if the function is given in term of x and you are testing for the negative and the positive values, and you are reaching at the same answer, so you must immediately say that y-axis is the line of symmetry for this function. Okay. So
Okay,
in this case, if you are asked to find the line of symmetry, so straight with answer is that y-axis is the line of symmetry of this function. So it's a
okay.
very simple now. I'm sure that now even function is very much clear, and whenever
Yeah, that's pretty
this
clear
is
now.
actually what we can say the algebraic problem. If there is a graph also, and you will have to test whether this is a symmetrical or whatsoever, we can say it's a even or odd. So what you will have to do, you will have to locate the graph, you will have to get the values corresponding to positive and negative if both are on the same shape. So you can say it's a symmetrical. And if the line, some line is dividing it into two equal halves, then you can say that this is the line of symmetry. Anyhow, so we are just moving to the next slide. Now let's see testing for even function. So once again, a better method is to use algebraic values of x, say x is equal to plus minus a. So once again, what we can say that the function is the same, and here what we are getting that if we are getting the numerical value out of the domain, if you can find the domain, so out of the domain, select a number, put it once as a positive, and second time put this number as a negative in the given function, in the given algebraic equations. So if you are getting the same answer, now this is the same as you can see over here, hence we can say is an even function. So this is the working rule. The what we can say the thumb rule is just put the positive and the negative value in the given equation. If the answers are same for the negative and the positive, so immediately your answer must be that this is an even function, and it also symmetrical about the y-axis. So I'm sure that this was the simple explanation and you got it. Now we are moving to the next one. So example, once again, comparatively, two examples are given. Now let's see. Please read this one. This on the left hand side.
Oh, I was muted. So one, prove that g of x is equal to x squared times x squared minus 4 is even as it is an even function. A proof statement requires that you start with LHS and arrive at the RHS. Gx is given if g of negative x is equal to gx by definition. Um, at x is equal to a, g of a is equal to a squared times a squared minus 4. At x is equal to a net minus a, g of negative a is equal to negative a squared times negative a squared minus 4. Um, g of negative a is equal to a squared times a squared minus 4. But g of a is equal to a squared times a squared minus 4. G uh, of negative a is equal to g of a. Hence, gx is equal to x squared. X squared times x squared minus 4 is an even function.
So this is once again one more function is given, and what you are doing, the same rule, the same procedure, only one step that you are replacing the x, each and every x for a number, positive number a, and next time you are also replacing the value of x, each and every x with the negative a. And this way, if you are reaching at the same answer, that the negative a of the function and the positive a for each and every x, the answer is same, then you can say it's a even function. Now let's see, this one is, please read this example 2.
Sure. Show that f of x is equal to cube, sorry, square root of x squared minus 4 is an even function. Okay. A show statement requires that you evaluate LHS and the RHS and show that they are equal. F of x is even if f of negative x is equal to f of x by definition. At x is equal to a, f of a is equal to square root of um a squared minus 4 at x is equal to negative a, f of negative a is square root of negative a squared minus 4. F of negative a is equal to square root of a squared minus 4. Hence, f of negative a is equal to f of a. Therefore, f of x is equal to square square root of x squared minus 4 is an even function.
Okay, so once again the same procedure. So when we are writing just like that, LHS left hand side and RHS the right hand side. So it's mean that we are just replacing on the left hand side, x is replaced by a, positive a or negative a. And on the same time right hand side, this is under the square root x square minus 4. So this is the value of the function. So this right RHS mean right hand side and LHS mean left hand side. So the procedure is same, you are reaching at the same answer and also at the same answer. So whatsoever the a is, a and minus a, that both are included in the domain of that function. So we'll have to check, I will have to select this a and negative a from the domain of the function. If the function is getting whatsoever the value is positive or negative as the same answer, so that will be traced on the same point. So it is also symmetrical about the y-axis and it is also even. So with these example, I'm sure that you are crystal clear about the nature of the function as per the even. Let's see the odd function. Please read this one from here.
All right. A function f of x is an odd function if f of negative x is equal to negative f of x for all x in its domain. An odd function has the important property point symmetry, a 180-degree rotation about the origin. This allows us to plot the top side of the x-axis, then to complete the sketch, draw a 180 rotated mirror image on the bottom side of the x-axis.
Okay. Now from here, what we can say the difference is that if a function fx is given and if it is an odd function, so what we'll have to do that if we are replacing its value with the negative function, negative x, that fx is replaced with the negative x. So this minus is coming out of the function. So that time we are getting the same, but here we are getting the negative sign, the negative of this function. Negative, my fx is given and you are replacing with minus x, so you are getting minus of the function. So negative sign is coming out for all x in its domain. Whatsoever the number you are selecting from domain, for each and every member of the domain, you are getting the same result, that the if you are putting the negative value in the function, negative value in the variable, So you are getting minus of that function, the negative function. So an odd function has the important property point symmetry. So point of symmetry, that was in the previous case y-axis. Once again, it's a y-axis, but now it's a 180-degree rotation about the origin. But I mean to
Right.
say, look at this. So if you are just bringing this one, this is your actual function y is equal to fx. So then to complete the sketch, how can we draw the 180 rotation mirror rotated 180 degree and mirror image on the bottom side of the x-axis? So from here you can see, look at this, this was the original, and this y-axis is over here, top sided of yx, fx, y is equal to fx. So this blue line is over here. And now we are looking for the other end. So bottom sketch of y. So this is the rotation of 180 degree. What I mean to say, that was in this first quadrant.
Right.
Now it is being rotated just like that over here. So it's a rotation, the anti-clockwise rotation of this. So when this is rotated to this will become 90, and one more 90 is over here. So in this way, this rotation is coming in this down, down. This is the fixed point, and you are just pulling from here and pulling down and down, and you are rotating it up to the 180 degrees. So you are just bringing it to here. So its a rotation is 180 degree. So in this way, this is just coming out to be here. The tip is not down. Here the tip was
Right.
up, and you are rotating it to 180 degree. So you are getting the complete function sketch. So this is the odd function. Now you can see that here if it is a even, now just visualize this one. If it's a even, so the symmetry, the other end is over here, just like that, upward, but in the negative side of the x-axis. Here, it's a totally change. What I mean to say, that this is the given portion of on the right hand side positive. Then if you are putting the negative value and you are getting a negative one, so the reciprocal of this with the sign is this one. And how we can get this? So rotate 180 degree. If the function is over here, so once again you will have to rotate over there. So you will get over here in this way. So in this quadrant, if that function is given over here. So I'm sure that this rotation and its completion and the line of symmetry and the other part of the function to complete it sketch is clear. Is there any confusion? You can ask now.
No, I understand. It's like the pivot kind of point, the
Oh yes,
origin. It just,
this
yeah.
origin is actually, it is rotating about the origin, because
Right.
this is that's why I'm saying just pulling down from the top. So here you are just pulling down, 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 and you are at the same time rotating it. This will be rotated with the origin. Its bottom will be rotated, and its rotation is always anti-clock. It's a now clockwise. It's a clockwise rotation because you are pulling down. So this will go in this way. So rotate it clockwise
Right.
through 180 degree. So it's a clock. It's a mirror image. What we can say, if we are just getting the mirror, but that mirror is rotated. If you are getting the mirror image, so that will be over there as like in the even function. But this is the mirror image is rotated through the 180 degree also. So that's why we are getting this red line downside. So if this type of function is given and nothing is written over here and there, so statement you must say that is it is an odd function, because just like this, and this is just like the same, going up and down. When you will find this, so definitely are these type of the function anywhere.
Right.
So those are symmetric about the above and the below of the x-axis. Then it's a very simple answer is that it's an odd function. Now let's see the example. Testing. How will test this? Please read this one.
Sure. Testing for an odd function. To test whether a function is even or odd or neither, work with f of negative x and compare it to f of x. Usually it's also better to use x is equal to a and x is equal to negative a as the two values for comparison. Example, show that f of x is equal to x cubed minus 4x is an odd function. Let's use numerical values such as x is equal to 4 and x is equal to negative 4. Let evaluate f of 4 in f of x, evaluate f of negative 4 in f of x. F of x is equal to x cubed minus 4x, and f of x is equal to x cubed minus 4x. F of 4 is equal to 4. F of 4 is equal to 4 cubed minus 4 times 4, and f of negative 4 is equal to negative 4 cubed minus 4 times minus 4. F of 4 is equal to 48. F of negative 2,
No,
f of negative
it's a
2
wrong.
is,
It's a sorry. Here
oh, it
you
should
will
be
put
negative 4.
4.
Yeah, okay. F of negative 4 is equal to 48. Now f of negative 4 is equal to negative f of uh, 4. Hence, f of x is equal to negative 3. F of x equal to negative, sorry, x cubed minus 4x is an odd function.
Okay. So x cube minus 4x is an odd function. So the test is the same. That once here on the left hand side you are putting the positive 4, and here the positive what I mean to say the negative 4. So the one correction is, so what we can say, look at this correction. So that should be, what I mean to say, that should be uh, the minus 4. That should be just like minus 4. So that should be the minus 4 instead of minus 2. There is the correction. So it will be minus 4. I'm sure that now the correction has been done. So it's a minus 4. That will be, once again, this is minus in the sense that it will be just like that, minus 48, and here you have positive 48. So we
Okay.
can say the minus f of x. So minus 4 and this minus is coming out. Only difference is of the minus 48 and minus 40. So that's why this function is odd function. Now let's see
All right.
testing. So how can we test for an odd function? So once again, we can say that a better method is to use algebraic value of x. Say x is positive or negative a. So fx is equal to x cube minus 4x, and fx is equal to x4 minus 4x. Now the two functions are given. So what we are doing over here, once again, there is a mistake. So that should be x cube. Okay, please correct this one is also. This is x
Yeah.
cube, the same function. Here we have x cube on the next step. So we are getting what? That f minus a minus f of x. So that's why it is the odd function. So now let's see, we are just moving to the next one. So next is just like this. Oh yes. So this was the testing and examples. Now you can see the example, so many examples are given, but to the point on the left hand side, that this is proof that fx minus x cube is an odd function. So from here, you can see that if we are replacing each and every x with the negative value of x, so fx is an odd function. If we are replacing each and every variable with a negative x, so we are getting the value of the function same but with a negative sign, negative of that function. So with a given example, f of x is equal to fx minus x cube. So if you are replacing this f with a positive a, so we will get 5a instead of 5x. So x is being replaced with a and negative sign as it is. And this is x cube. So we will replace x with a because x is equal to a. So we'll get x cube. Are you getting me?
Okay.
Okay.
Yeah.
Now, at the same time, we will have to test this also at the x is equal to minus a. So here, once again, we are replacing each and every x with minus a, with negative a. So this will become f of minus a, and this is equal as it is. 5 is coming as it is. So x is being replaced with the negative a, and this minus sign as it is. And once again, this x cube is replaced with the negative a cube. So we are multiplying now minus 5a, and this minus and minus, the negative and negative will become positive over here in the next step. And from here we can take negative as outside the brackets. So this negative is coming outside, so this will be positive, and when there is a negative sign outside the bracket, so inside change will be reversed. So this positive is becoming negative now. I'm sure that you are getting this step. It's a simple algebra. Are you getting
Okay.
this? Minus
Yeah,
a.
I understand.
Okay. So from here, once again, this is the value of the same that we FA is this one. So FA is this one also, but with a negative sign. So negative is coming. Now you can see this FA 5A minus A cube, and F minus A is the same, except this is the same. This is FA, and only negative sign is extra. So negative sign is coming as here. Hence, this is an even odd function. Show that. So one more example is this. So once again, we are putting the a and the negative a. When we are putting a, we are getting this one. And when we are putting minus a, negative a, we are getting this one. This.
Okay.
So once again, the value at the negative is minus f of the positive value. So here, once again, this is an odd function. And if the examples are, if the algebraic expressions are given, so you will have to do this and you will be in a better position to get the answer, whether the function is even or odd.
Okay.
So neither, now there is a what we can say, so situation is in between, neither even nor odd. So what type of this, neither, a mix of even and odd exponent. What I mean to say that, let's see the example. Fx is equal to 5x4 plus 2 over 3x cube. And the second example is 6x cube plus 2. If you are putting, replacing x with the positive and the negative, so nothing is there. The values of the functions are totally different. You are not getting the same values. So these type of the functions are called neither even nor odd because they are not satisfying the condition definition of even and odd. So example is, now look at this. This example will explain how we can say neither an even or odd function. Example is this, show that f of x is equal to square of x plus x is neither an even or odd function. To show or to prove that function is neither odd or even, you need to show both the function both the following two conditions. First is if fx not equal to f of minus x. And the second one is that is about the even condition, even function definition. That f of the function is not equal to the value at the negative x. And the second is that you will have to show that it is not the negative of the function at negative x. Are you getting this? These are the two conditions.
Yeah.
So you will have to check both of these. So first, if you are putting the positive value, so you are getting this one. And then you are putting the negative value. So you are getting this one here. So this is a square and this is minus a. Only difference is of the sign. So this is minus, but minus a is equal to a square minus a. So in this way, both are not the same. There is a, so now if a and minus a, f of a and not equal to f of minus a, and f of minus a not equal to minus f of a. Both the conditions are not same. Look at this. This is f of a, this is f of minus a, and this is minus f of a. So these three blue lines are totally different. So that's why we can say neither an even or odd. So please, these are the examples also. And you can find many more examples. So this is even, this is odd, this is neither even or three types of the functions are given. The last one is neither even or odd. Now let's see exercise. So please take the screenshot of this. I will send you the slide, but in the meanwhile, you can take the screenshot to do something at your end. Are you
Okay, I
taking
took
this
it. Yeah,
screenshot?
yeah, I took it.
Oh, yes, sir. So these are 1, 2, 3, 4. The answer is for each and every one, the answers are given, but you will have to test and you will
Right.
have to work out on the paper and send those workings to me. You can WhatsApp to me. So it's done from your side if you are just doing that for the test. So this will be neither even nor odd, and here you can test for the even test. So these are the answer, but anyhow, you will have to work out all these independently. So if you have a screenshot, is there any confusion? Can you solve all these?
Yeah, because I could just do like the thing that we just
Okay,
did with
okay,
the, yeah,
okay,
negative.
okay.
And all that.
Now let's see. We are, so the second part is just a very smaller portion of that is that we will talk about the increasing function and decreasing function. So let's see. So that is called, please read this one.
Sure. Monadic functions.
Yeah.
So a function is monotonic or tonic. Okay. If it's increasing or decreasing on an interval.
Okay. Actually, monotonic functions, a function is monotonic if it is increasing or decreasing on an interval. So increasing and decreasing functions. So monotonicity of f of x is that interval AC, it's increasing. You can see, look at this AC. During this interval, the function is going, starting from here and going up, 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 and reaching at the top. I'm sure that you're looking this figure.
Yeah.
And then from C to D, it is decreasing, coming down. So C to D interval, this during this interval, decreasing. Look at this, C and coming down to D. And once again, it is going up. So zigzag from A
Right.
to, from D to B, it's increasing once again till B is reaching. So at dB interval increasing. So in this way, the function is behaving just like that, that in the within the given domain, sometime it is going up and coming down and then going up. So decreasing, increasing. So that type of the function is called monotonic function. So if the sketch is given, if the graph is given and you are asked to find the nature of the function, so you will have to clearly look at the shape, look at the tracing or the graphing of the plotting of this function. So immediately you must see that at some interval it is increasing and on the same time it is a decrease also on the other interval and then decreasing or increasing. So this may continue so several times. So that's, you
Right.
can say that's monotonic functions. So let's see. increasing decreasing function. So it's a very simple test. Now, given function f defined as an interval for any two numbers x1, x2 on the interval. So increasing function is that f at the x1 is less than f of x2, where x1 is less than x2. So here you can see from the figure that if this x1 is less than x2, because this is on the x-axis, so this value is less than this x2, or you can say on the other end, on the positive side is also, so x1 and x2. So this is our region. So you are getting this value for the x1, and further x2 is greater than x1. So if the function, if you are putting the values in the function, so fx is greater than, less than f of 2x, just like that. So then we can say it's a increasing. And if the reverse, that if x1 is less than x2, you can see over here in the negative side that this is less than this x2, or this is less than this one. So if the value is greater than f1 at first point is greater than, and f of x2, then you can say that the function is decreasing. I'm sure you are getting this two definition.
Yeah.
One is for the easy learning, you can say that just get the 2 points from the domain. One must be less than the other one. And if you are putting both the values, if the function is less than at the first point, then the second point, then it is increasing. If the situation is reversed, that it is greater, you are getting the greater value at the smaller value from the domain, and you are testing the second point, which is greater, but the value of the function is coming lesser. So becoming this situation, then you can say decreasing function.
Okay.
So I am sure you are getting this. Now we will solve the example. Increasing decreasing function. A function is increasing when its graph rises as it goes from left to right. A function is decreasing when its graph falls as it goes from left to right. The same is, look at this. So here from here it is going left to right, but always going up. So it's a decreasing. From here it is going left to right, but it is coming down. So it's a decreasing now. And once again, from this point, it is going up and also going to the right side. So it's
Right.
increasing. So one function may be decreasing and increasing simultaneously. So we can say from this point, it is moving right and also increasing. And from this point, it is moving right, but also decreasing, coming down. And reaching at this point, so once again, it is picking up, going right as well as to the up. So during this interval, it will be increasing. And during this interval, it will be decreasing. I'm sure that increasing this decreasing function, that graph shows the actual nature.
Right.
Increasing decreasing function, one more thing is the increasing decreasing concept can be associated with the slope of the tangent line. The slope of the tangent line is positive and the function is increasing. The slope of the tangent line is a negative when increasing decreasing. So this is the most informative and the most important. So if you are asked in terms of tangent, so anybody can ask if the tangent of a line is positive. So what is the nature of the function? So you must immediately say it's increasing if tangent is positive. And if the tangent is negative, you must say it's a decreasing function. And what is the tangent now? Question is for you. What is
Oh,
tangent?
the slope of the.
Yes, it's a slope, it's an angle. It's an angle of inclination, or you can say the slope tangent line, as you can see from here, that these red lines are touching the curve at one point. So that's why these are called the tangents. So
Right.
if the tangent is positive, here the tangent is negative over here. So you can see the this tangent is Red lines tangent are positive because it's going up. These are the positive
Right.
tangent. And when it is tilted towards the left, it is decreasing. As you can recall when we were talking about the function that if the function is tilted towards the right, it's always a positive function. And when it is tilted towards the left, then it is negative function. So at that time, we were talking about the positive and the negative. So that was all about the tilt of the tangent. That is the slope. And you can just recall the gradient. What I mean to say, what is gradient?
Gradient, isn't that just like
Gradient is a slope. Gradient is the rise over run, the ratio of rise over run.
okay, so gradient is just another word for slope.
Oh, yes. Actually, gradient is the ratio between the rise and the run. What I mean to say, rise and run mean that it is rising, it is also running. Rising and running towards the right. It's
Okay.
once again what we can say running, but it's down. So once
Okay.
again from here it is rising as well as running to the right. So ratio, and that's a gradient is also the rise ratio of rise to the run. Slope is also the inclination, and in M is used for the slope. Gradient is the same slope, and tangent of that angle is also called the inclination of the slope, the functions of the lines. So what all about that is the tangent. So all these things are linked together. We will talk about that. Definitely a lot of things are coming, and we will talk about the gradient of a line. We will talk about the slope of a line. We will find the ways and the methods and the formulas, how to find the gradient, how to find the slope, how to get the tangent of a theta. So how we'll calculate the angle of inclination. So this is all about that. But anyhow, at this stage, you must keep only one thing in your mind, that if the tangent is positive, that tangent is positive, which is going upward, then we can say the function is increasing. And if the tangent is negative, it's coming down, then we can say at that point, during that interval, the function is decreasing. I'm sure that this slide is clear to you.
Yeah.
Is there any confusion? You can ask now.
No, I think I get it now.
Okay. So moving to the next. So increasing, decreasing function. Please read this one.
Sure. Increasing, decreasing function on an interval which is f, on which f is defined. A if f of x. Wait, what is that? If that's f of x,
Oh,
right?
yes, yes. Look at this. This is slightly changed. Actually, this is the prime. F prime of x means the first derivative. Do you know
Oh,
the
okay. So
derivative? What is derivative?
I know what prime is. Like the it's like a
Derivative dy by dx. Okay.
uh I'm not sure.
Differentiation. Differentiation.
Oh, okay.
Okay. Anyhow.
Yeah, so if f prime of x is greater than 0 for all x in an interval, then f is increasing on the interval. If f prime of x is less than 0 for all x in an interval, then f is decreasing in on the interval. If f prime of x is equal to 0 for all the x in the interval, then f is constant on the interval.
So actually, this is what we can say the for the maximum value for the extreme values. That was also included in all in those. I have seen your screenshots, and there was the extreme values. So this test is being used for the extreme values. But anyhow, I will tell you how to find the derivative of a function. So this is the prime. Prime is the f prime x. That is called the derivative. We'll talk about that. But this time that this is not our topic, but this is just only the test. If the derivative during the interval is greater than 0, the function will be increasing. If the derivative of the function that derivative is also dy by dx is also the inclination. The dy by dx is also the tangent. Dy by dx is also the gradient. Dy by dx of a function is also the slope. So these are interlinked between the things. If the things are given algebraically, then we are finding the derivative. We are applying the derivative test. That is, if the function is given, just to get the first derivative of that function with respect to that variable, and just put the value out of the interval, out of the domain. So if the value at that point of the domain is, the derivative of that value is greater than 0, then you can say it's increasing during this interval. And during this other interval, if the prime f prime x, that is the first derivative of that equation, is less than 0 during another interval, then you can say this is decreasing from this point to that point. And all of a sudden, if you are getting the value 0, so this will be the constant function. Constant function. So another definition is, if you are if somebody is asking you that what is the constant function, simply say if its the first derivative is 0 at that interval during its domain, then it will be a constant function. But anyhow, we'll talk about that also. But
Okay.
this was just the test for the increasing and decreasing. If the graphs are not given and you are just given the algebraic equation, so first and derivative test is just like that. Anyhow, so for more videos, so we have a lot of videos about all these topics, including the set, including the functions, their graphing, quadratic function, parabolas, a lot of, almost more than 100 about these topics are available on this link. So this is a YouTube channel. So you can visit, you can subscribe, you can share, you can talk to your friends
Okay.
just to get all these things.
Yeah.
And in your own time, if you are looking for any topic or any problem, so you just have to write that name of that problem, name of that topic, and immediately there will be a few videos that may be useful for you. But anyhow, thank you. Thank you very much for today. So we will talk about the next topic about the functions, that will be very soon. Anyhow, thank you very much. So it's all about that. So Allah Hafiz.
All right. Allah Hafiz.